Hello and welcome to the Analog Devices Precision Training video, which focuses on switch and multiplexers technology. This video is the fifth in the series, entitled VT1005 AC Parameters and Timing Specifications. In this video, the learning objectives will focus on the following: AC parameters, such as switch bandwidth, switch-off isolation, crosstalk phenomenon, and the switch insertion loss. Thereafter, some switch timing specifications will be discussed, such as the turn-on time, turn-off time, break before make, and make before break times. The bandwidth frequency provides a measure of the high-frequency usefulness of a switch in the on state. Bandwidth is specified as in the plot shown, as the frequency where the input signal gain is attenuated by a -3 dB as shown in the graph. This means that the switch can pass input signals up to 300 MHz without significant attenuation. For DC or low signal frequencies less than the cutoff frequency FC, the attenuation of the input signal is much less. At higher signal frequencies, the impedance provided by the resistive and capacitive network becomes severe, resulting in additional attenuation of the analog input signals. Thus, the bandwidth is limited by the switch-on resistance, or on, the drain capacitance, CD, and the external passive components, C-load and OR-load. The off isolation is a measure of the ability of a switch to impede or block signals presented on the source pin when the switch input channel is in the off state. In the simplified model of the off switch, the source-to-drain capacitance, CDS, couples some of the input signals on the source, S, to the drain, D, output. As the frequency of the input signal increases, CDS will provide less impedance to it, allowing more of the signals to appear on the drain output. With increasing frequency, the switch-off isolation decreases. Small CDS and OR load values, coupled with larger CD and C load values, will present a switch to have a high off isolation value. Crosstalk is the measure of cross-coupling between switch channels. It is given by the equation 20 log, V out over Vs. To further understand crosstalk in the context shown, let us investigate the switch simplified model on the right. As the input signal frequency applied on the SB, i.e. the on switch, progressively increases, the drain-to-source capacitance, CDS, of the off switch, SA, lets a small signal pass through. At higher input signal frequencies given to SB, the impedance of CDS of the off switch, SA, decreases, thus allowing more signals to couple through to the source input, SA. In addition, the parasitic source-to-source capacitance, CSS, between SA and SB also couples signals from channel SB to channel SA. For non-adjacent switch pins, the crosstalk phenomenon decreases even further if the switch inputs are on opposite sides of the die package. Good layout techniques are vital in reducing crosstalk. The figure shows how insertion loss is measured. Insertion loss occurs when the switch is in the on state, It is the measurement of the small signal attenuation or loss caused by the on resistance of the switch and can be calculated using the equation insertion loss is equal to 20 log Vout over Vs, whereas Vout over Vs is equal to RL over RL plus or on. Looking at the attenuation or insertion loss versus frequency plots, we can see the contribution of different or on resistance values when the switch is in the on state. For the ADG5212, its or on is equal to 160 ohms. For the ADG1412, its or on is equal to 1.5 ohms. For the same frequency measurement from DC to 100 MHz, the ADG1412 switch with or on is equal to 1.5 ohms experiences marginal signal loss. When compared to the ADG5212 switch with or on is equal to 160 ohms, the signal loss there being -7 dB. With increasing frequency, the insertion loss is increasing. Turn on, T-on, time, is the time delay after selecting the input switch on path and the output signal rising to 90%. Turn off, T-off, time, is the time delay after selecting the input switch off path and the output signal falling to 10%. TBBM, the break before make switching, guarantees that the switch breaks open the first set of contacts before engaging, closing the new contacts. This prevents the momentary connection of the old and new signal paths to the output, reducing click and pop sounds. The off time or on time is measured between the 80% points of both switches when switching from one address state to another. MBB in a switching device is the configuration in which the new connection path is established before the previous contacts are opened. This feature helps to prevent a switched path from ever seeing an open circuit. The on time is measured between the 80% points of both switches when switching from one address state to another. Some of the key takeaways from this lesson for a switch is that the switch bandwidth is limited by the resistance and the capacitive network around the switch, such as the on resistance, drain capacitance, as well as the load resistance and the capacitive load. For the off isolation, small CDS, the source-to-drain capacitance value, will present a switch to have a high isolation value, thus less coupling of high-frequency input signals. For insertion loss specification, a switch with the lowest on resistance will experience marginal signal loss when compared to a switch with a higher on resistance. ADI has a large portfolio of switches to meet customers' application design. ADI Switches offers high signal bandwidth, excellent off isolation in applications that demand it, as well as the break before make features. Please visit analog.com/switchesmultiplexers to see examples of switches on offer.